Well, thank you so much, ladies and gentlemen. And I just want to welcome you back to our beautiful course looking at the chemistry, which is the central science. Now, there are a lot of questions that you're supposed to ask yourself just by looking at the title itself when we talk about chemistry, the central science. Now, take note, we've got different types of sciences, such as physical sciences, you've got the natural sciences, you've got environmental sciences, life sciences, etc. Now, when we say chemistry, the central science. This is the science, which is at the center stage. So we are going to start with your chapter 1 so that you begin to understand what we are dealing with. So I'm just going to take you down there so that we look into your introduction. Very, very important. As you can see, we are going to introduce you to matter, energy, and measurements. Without wasting much of the time, you can see the title of this book, Chemistry, the Central Science, is a book that has been presented by different experts in the field. So these are experienced campaigners, experienced chemists, who've been university lecturers, and they come to you with a lot of information. So in another way, they are trying to assist you to reflect the fact that much of what goes around in the universe, what goes around in the world that's around you, involve the principles of chemistry. I hope you pick that point. So the universe, which is around you, you can think of your natural environment, the food that you eat, the things that you drink, and so forth, the type of lotion that you apply on your body, and so many more. Everything, they rotate under the concept of chemistry. What type of chemicals did they use? So, everyday chemical processes that take place. There are different types of everyday chemical processes that are taking place in the industry, in laboratories, and so forth. So you can see there, everyday chemical processes, they include the changes that produce your brilliant four colors in your leaves. So if you had to go outside there, especially in spring, when the flowers, they are just budding, they are simply coming out and so forth. So you are being advised to consider those changes like in color. The basic question is, what triggers that? And if you are to go, for instance, in biology, which is another science, you begin learning about the issue of the deoxyribonucleic acid, which is the DNA, how the DNA contain what we call genes that are responsible for different expressions and so forth. But have you ever asked yourself a question to say what type of chemicals are involved when you look at the colors of your flowers? Some might be purple, others might be red in color, white, and so forth. Look at your leaves, the production of chlorophyll. So if you are to go inside of the leaves, you are going to discover they've got chloroplasts, which produce chemicals. And if you look into that pigmentation and so forth, you need now to begin to analyze what type of chemicals, are involved in the production of chlorophyll. So the way our bodies process the food that we eat, the electrical energy that powers our cell phones and so forth, all of those, they involve different chemicals, So if you are to look into your cell phone, for instance, consider what is consisted in the cell, in the battery. What type of chemicals did those guys in electronics, what type of chemicals did they put there? So we are presenting to you, which is chemistry, the central science. Now follow me, and we're going to have a good time together, as you can see there. Let's look down there. It says, chemistry is the study of matter. I like that. It's a study of matter. And we say, what is matter? Then we say anything that occupies space. Space. Everything that I'm touching is part of the space. I've been saying the universe is the massive space, that contain different smaller bodies. So if you are to go scientifically to consider the planets, those are just small bodies. If you are to consider the millions, in fact, billions of stars in the galaxy, all those are part of what? Small bodies that are found in this huge space that we call the universe. So when you say chemistry is the study of matter, we are actually studying different processes that are taking place in our cells, the different processes that take place maybe in your blood, the different processes that take place in the atmosphere, and so forth. So it's a study of matter. Its properties. Now, I like that where they are talking about its properties. I think that one is the gist of the study, is for you to try to know the properties. What is the behavior? How does this, gadget, how does it behave? How does it react? If we trigger, we put something there, maybe we connect some wires and so forth. What happened? So begin to find out the behavior of a system. Begin to find out the properties of what you are dealing with. In a nutshell, what is this thing made of? Is it a cell phone? Is it a laptop? Is it the engine of an aeroplane? Is it the engine of a car? So you need to find out the different chemical processes that powers the engine, the different chemical processes, that make a machine to be in a motion. So when you talk of locomotives and so forth, you need to begin to understand, look there, the study of matter and its properties and the changes that matter undergoes. For example, we often talk about the change from gases, the change maybe into a solid, from a solid into a gas, the three states of matter, where you've got gases, which is in gaseous, then you've got other things that could be liquefied, that's in liquid state. Then we've got other stuff that are solidified, which are solids and so forth. Of course, we must begin to understand there is the fourth state of matter, which is plasma. So that is the fourth one, which, you guys, the scientists, you are currently working on. So you are busy studying the plasma and so forth. So back to this. Take note of the changes that goes on in the system. As you progress in your study, you will come to see how chemical principles, there are different chemical principles. And I need maybe to shout, to scream at you so that you understand what we are talking about. When we talk of these chemical principles, they were born from human beings just like yourself, born out of observation. That's how science works. So when you consider the issue of a scientist at work is dealing with issues of observation, the changes taking place within the system, is analyzing, is trying to understand, to navigate through what happens if we put 1 and 2 together. What are we going to get? So as they do that, through observation, they begin to come up with a generalization. I think, the issue of an hypothesis. That's the first step. Before you can even begin with your experiments, you need to come up with an hypothesis, which is simply a guesswork of your results. You want to guess before you even start your investigation. You've got an idea what's going to happen if you combine this chemical and that other chemical. Then so there's going to be a huge spark in the system, So in short, we are talking about different chemical principles which have been formulated by our great scientists who have gone before us. They have come up with different principles. For example, in physical sciences where you talk about Newton's first law, Newton's second law, the third law, and so forth. You need to understand maybe the principles of gravitation forces and so forth. And in looking into this topic, we shall be looking into the different chemical principles that operate in all aspects of our lives, from everyday activities, when you are involved in food preparation, which is another big industry, by the way. So we've got those guys who are chefs. So when they are busy combining different chemicals, so you need to understand the principles that goes on. What does this mean? For instance, if you've got different spices, how do you combine them? How do you put them together? When you are adding your salt, how do you add your salt? When you are measuring your water and so it's part of chemistry. So you must begin now to see what goes on, for instance, in food preparation to more complex processes such as those that operate in the environment around you. I hope you are picking those points and understanding them. We will also learn how the properties of substances can be tailored for specific application. I like that point. You can tailor them for specific application. Is it in pharmacology, where you are busy making different type of medications? So you are able now to tailor the different type of substances because at the end of the day, this is what we want to produce. So you guys, as you begin to do your practicals, you go in your laboratory, you've got a mission, you've got an objective that you wish to accomplish. So they said to you, we also learn how the properties of substances can be tailored for specific application by controlling their composition and structure. By controlling what? Their composition. But I'm going to add something there. By controlling their chemical composition. So you need to understand what type of chemicals are they made of, what type of chemicals are they composed of, and so forth. So you are able to monitor, you are able to manipulate. I think you know how you work with your independent variables, where you have been given an opportunity as a chemist, you have been presented with an opportunity to manipulate. You can make some changes and you change some structure and so forth. There is an example which has been presented to you. For instance, the synthetic pigments chemists developed in the 19th century were used extensively by Impressionist artists like Van Gogh and Monet. Well, those are names of some artists who did a lot of manipulation of synthetic pigment chemistry, changes in color. When you are mixing different substances together, then you begin to analyze the type of changes that goes on. I can give you a simple example. You've seen, for instance, when you want to test for your pH, your potential hydrogen in a substance. So we use different type of indicators, and you start checking or analyzing the changes of colors, then it will be able to determine whether a substance is acidic or a substance is what? Is a base, it's a basic, and so forth. Then when you are mixing different colors together, then you want to come up maybe with a different color and so forth. So this first chapter that you are dealing with provides you as a chemist, as an upcoming chemist, with an overview of what chemistry is all about. Wait a minute there. What chemistry? No, pause there. What are chemicals? You see? So on your periodic table, you are presented with different chemicals that you can begin to manipulate. So you've got your sulfur, you've got your sodium, you've got your chlorine, you've got different type of chemicals, For instance, another example that we can look at is within the soil. So the soil is composed of different chemicals. So when you look into the composition of those chemicals, then you begin to understand what type of a chemical are we dealing with. When the roots are absorbing the nutrients, they're absorbing water and mineral salts, what type of mineral content is needed and so forth. So you must begin to have an overview of what chemistry is about. What do chemists, those professions, what do they do when they are inside of the laboratory? You guys, you call it chemical engineering. I like that term, chemical engineer. You know, you want to engineer something using different chemicals. What are you doing? It's a manipulation. You have to make changes, you know. So it's simply for you to become a little bit clever how you manipulate the different chemicals that have been presented before you. So there, what is ahead? List gives an overview of the chapter organization and some of the ideas that are going to be considered in this, you know, your studies or in your book and so forth. So some of the topics, as you can see from 1.1, the study of chemistry. This begins to open your scope. Why must you study chemistry? So you have to learn what chemistry is all about. What do these guys, the ladies and gentlemen whom you call chemists, what do they do? And why is it useful for a 21st century person for you to study chemistry? I hope you are picking those points and also understanding them. Then later on, we shall go into classification of matter, the properties of matter, the nature of matter, so the nature of energy, units of measurement, uncertainty in measurement, then dimensional analysis, and so forth. I just want to go to the next page. So there we go. Let me just punch it like that and become faster. There we go. The study of chemistry. So we are now starting with your chapter 1. So now, chemistry is at the heart of many changes, the main changes that you see in the world around you. For example, the changes that you see in the fireworks, when things begin bursting into the atmosphere, the changes that you see when an atomic bomb is exploding, the changes that you see during sunrise, sunset, and so forth. So chemistry is at the heart of the main changes that you observe in your nature. And it accounts for the myriad different properties, you know, that you observe in matter. Matter is anything that occupies space, and the space is the huge universe around you. So to understand how these changes that are observable, these changes that are obvious, and the properties, the different properties that they present before your table, we need to look far beneath the surface, you know. What is triggering those changes? What is causing the light to shine? What is making the colors to change? So you need to go a little bit beneath for you to begin to understand the different processes that are taking place. So, as you can see, to understand how these changes and properties arise, we need to look far beneath the surface of our everyday observation. So you need to go just a little bit deep and try to understand what could be the reason for all the changes. For example, even aging, when a human being starts aging, you need to begin to understand the changes in chemical composition of the human body. So you can't be the same from the time you were a baby to the time when you are 80 years old. There will be a lot of changes. So we want now to go a little bit just deep to say, within the cell, what are some of the changes that are taking place? Within the system, within the engine, and so forth. So let us begin by looking into the atomic and the molecular perspective of chemistry. So let's start from there. Just need to go a little bit up, so bear with me there. Just pushing the page. Okay, so we are there now. The atomically. So atomic, let me go a little bit backwards. What's matter? Matter is anything that occupies space. But you need to know, matter is composed of smaller particles that we call atoms. So an atom is the smallest basic unit of matter. That's the smallest thing on planet Earth, if you wish. So an atom is the smallest basic unit of matter. So everything around you, they are made of atoms. Are you thinking of your water? Are you thinking of your solids? Are you thinking of your gases? Doesn't matter what you are dealing with. Is it oxygen? Oxygen is made from oxygen atoms. Are you thinking of carbon? Carbon is made from carbon atoms. Are you thinking of chlorine? It is made from chlorine atoms. Are you thinking of copper? Copper is made from copper atoms and so on. So you need to begin to understand the atomic and the molecular perspective of chemistry. So chemistry is the subject which involve the study of the properties and behavior of matter. You are done and dusted. So already now you begin to understand the work of a person whom you call a chemist. So this is an individual who wants to know, they want to exploit, they want to understand the different properties, of matter. Now, you see, out of curiosity, this is how they have discovered most of the stuff that we use today on planet Earth. So if you lived like 500 years ago, if you lived, let's say, 700 years ago on Earth, life was not what you see today. But the start started from those guys. They wanted to know. Out of curiosity, they wanted to study, the universe. They wanted to explore. So the more they did that, they made observation. They didn't just make observation, they jotted down everything that they observed. So they wanted to know about the different properties, the things that we observe, the behavior. Why do things explode? Why do we have hot temperature? Why do we have cool temperature and so forth? Matter is the physical material of the universe, the things that you can touch, the things that you can see. What do I mean by that? Matter is the physical material. You are able to see. You can even touch your liquids. You are able to see your solid and so forth. But I'm not sure if we're able to see the air. We are able to see it blowing, knocking things down, and so forth. We are able to see its action. So that is the physical material of the universe. It is anything. I like that word when they say it's anything. What does that mean? It simply means anything around you. So don't say undermine anything. It could be a toilet tissue. It could be your keys. It could be anything, because they say to you, it is anything that has got mass and occupies space. So you are able to see there are a lot of things that have got mass and they occupy space. So meaning within the universe, they've got a certain space which they occupy. That could include myself, why I'm occupying a space. It could include yourself, why you are also occupying a space. So a property. So before we do that, I hope you've understood what is matter. It's the physical material of the universe, which is anything that has got mass. So this is the key part, anything that has got mass and can occupy a space, okay? So to make it simpler, you simply go on your periodic table. That's why you've got a mass number. There's atomic number, then there's also mass number. So it has got a mass. So all those elements have been measured. What is a property? A property is any. Now, I like listening to the words. They say any characteristic that allows us to recognize a particular type of matter and to distinguish it from other types. You are able to recognize this is hydrogen, and you are able to differentiate hydrogen from sodium. I hope you picked that. That was nice. So you are able to see any characteristic, because you remember, matter does not have the same behavior. For example, some of the elements might be very reactive, You just mix them with, for instance, with water. Then you see the way they are going to behave. You mix them maybe with diluted acid, and you will see the behavior and so forth. So we are saying to ourselves that a property is any characteristics that allow us to recognize a particular type of matter and to distinguish it from other type. So you are able to differentiate, okay, this one is sodium chloride, which is your table salt. No, this one is a sulfur, whatsoever you call it, sulfur dioxide, if there's anything like that, whereby you mix your compound, your chemicals together, and you produce compound and so forth. So be able to differentiate and distinguish stuff. This book, your body, the air that you breathe, the clothes that you are wearing are all samples of matter. You see now, that becomes simple. We observe a tremendous variety of matter in the world, in the universe around us, but countless experiments by different scientists, different chemists, they have performed a lot of experiments have shown that all matter is comprised of combination of only about 100 substances. Have you seen? Which you call your elements. That's why I've started referring you back to your periodic table. So what it means, almost everything that you see on planet Earth, they are made from the elements that you see on your periodic table. For example, the element carbon. The element carbon is the composition, the largest composition, for example, of your body and so forth. So when you look at different substances, you need to ask yourself, what are they composed of? And you are going to be shocked. Almost all substances around us, they are composed of those chemicals that you observe. For instance, the food that we eat. All the food we eat, they contain, I can give an example of your carbohydrates or your starch. They are made of the elements carbon, hydrogen, and oxygen. So you've got C6, H12, and O6, which is your glucose, and they form a chain, glucose plus glucose plus glucose. Eventually, they are going to form your starch. You can look into your amino acid. So your amino acid, which form your proteins, they are also made of the same. They've got your carbon atoms, they've got your hydrogen atoms, they've got your oxygen atom and nitrogen. That's why those are nitrogenous substances. Where do you find nitrogen? It's on your periodic table. It's part of your elements. Where do you find your sulfur? Sulfur is one of the elements, So almost everything, you go to a medical doctor, they will tell you you've got a deficiency, of iron. Then they give you some supplements, some tablets to go drink. What did they use to make those chemicals? They use the elements. So we're making our life simpler. So if you thought like chemistry is this thing very difficult and so forth, no. Just cool down and begin to understand what you are dealing with. Now look into this. One of our major goals, who are these? You chemists, one of your major goals will be to relate the properties of matter to its composition. I like that point. You want to begin to understand the properties of this thing that you are dealing with. What is it composed of? That make you to open the system. You want to investigate the type of chemicals it is made of. That is to particular elements it contains. You want to find out, you want to go to the bottom, you want to find out what type of chemicals. And guess what? That is the work of chemical engineers. Chemistry also provides a background for understanding the properties of matter in terms of atoms. We mentioned the issue of atoms earlier on. The almost infinitesimally small building blocks of matter. So these are the smallest building block of matter. So if you wanted to know the smallest thing that make up matter, it is known as an atom. Take note of that. Each element, where on the periodic table. So all you need is that document you call your periodic table of elements. So each of those elements is composed of a unique kind of atom. What does this mean? Copper is only made of copper atoms. It doesn't have any silver atom. Once that happens, it's no longer called, an element, or what is it an element? Yes, because it's a pure substance. It's now going to be called a compound. So those will become now our compound. So a compound is a mixture where you've got this element plus a different element. Then we create what we call compound. But when you talk of an element, elements are made up of the same type of atoms. Consider oxygen, which is the atomic key, O2. Your oxygen is made up of oxygen atom. It's a pure substance, so it's not a mixture. So when they say to you that chemistry, is that a part? No. Each element is composed of a unique kind of atom. We will see that the properties of matter, they relate to both the kinds of atom the matter contain. What type of atoms does it contain? That is what you call composition. The word composition means what is this thing made of, you see? And the arrangement of these atoms. We've got those electron shell. For instance, that the first shell can only accommodate how many? 2 electrons. So it doesn't have 8. No, it's only 2. Then the second one is the one that is going to accommodate 8. Then you jump into the next accommodate, is it 16 or 18, and so forth, So you need to see the structure. So depending on the positioning of an element, for example, the first one will be the smallest, which is your hydrogen. Why? It has got only 1 atom. So if you go into your helium, it contains 2 atoms. But the more you go down, you begin to notice that the atom, the structure is becoming larger. For instance, if you are to compare your hydrogen and your chlorine, you will see there will be a massive difference in terms of a structure. Why? Because your chlorine contains more than 30, of those electrons that are involved in the forming of the structure. So take note of that in terms of composition. Composition, what is it made of? Then we begin to arrange those electrons in the shells and talking about issue of energy at a later stage so that you begin to understand what goes on within the shells. I hope we picked that point there and understood. Now let's continue. In molecules, 2 or more atoms are joined in specific shapes. You see? So where you are going now to form molecules, you are now going to have 2 or more atoms that are going to be joined. That's why you've got chemical bonds, by the way. So take note that these things are held together by different types of bonds. And later on, you must begin to understand what type of a bond you are dealing with. Some bond might be very strong, other might be very weak, and so forth. Throughout this text, you will see molecules represented using colored sphere to show how the atoms are connected, like you're just going to see about in figure 1.1. So they will show you if, for instance, we've got carbon dioxide. So they are going to show you how carbon and hydrogen, they are joined together. So when it's a CO2, you've got one carbon atom and two oxygen atom. So that's the one they are going to show you in the coming figures. The color, you see they are in different colors. You are able to see there. The colors provide a convenient way to distinguish them. So, which molecule has the most carbon atoms? How many carbon atoms does it contain? So, this is hydrogen. If you look into the structure, so just for you to understand, do you see where I'm pointing? So if you check, those are your hydrogen atoms. You are able to see them, the one in white color. Those are your hydrogen atom. Then this is oxygen atom. So you are able to see the oxygen atom. You are able, and you need to count them. Like 1, 2, 3, 4. So it is 4. So you say O or 4. Then this is the carbon. Now, let's consider the different substances. Oxygen atom, you can see it is a diatomic. By the word diatomic, we mean it has got two atoms, 1, 2. So it's a diatomic. Now, in the substance such as your water, you can see that water is made up of one oxygen atom which gets joined to two hydrogen atoms. So that's why you've got your H2O, H2, 1, 2, and the one oxygen atom. Then look into ethanol, which is an alcohol. So if you check, you need to see how many hydrogen? 1, 2, 3, 4. Is that the one also there? Are they 5? Then you look into your carbon, 1, 2. Then check your oxygen. Now look into aspirin, which is a medicine, by the way. Now look into aspirin. Look, for instance, the carbon atoms. There are a lot of carbon atoms, if you can see, in aspirin. Then look into your hydrogen, your hydrogen and your oxygen. Then you've got the ethylene glycol. Once again, you need just to see how many of those are they composed of. Then the carbon dioxide. So you see now, it starts making sense. It starts becoming simpler for you. So molecular models such as this, they assist you as a chemist to simplify your job. So the white, the black, the red sphere represent different atoms. So this is the formation of compounds. So these are not elements. They are now becoming molecules because you've got different type of elements. So they are all from your periodic table, but they join together. So they are chemical bonds that are involved to form ethanol, to form aspirin, the ethylene glycol, carbon dioxide, your water, and so forth. So we're going to take a break shortly. I just want to see maybe if we can make a little bit there, then we shall break off from this study. So, for example, by now you must have noticed that the molecules of ethanol and ethylene glycol, the one that we have just seen previously, have different composition and structures, meaning they do not have the same amount of carbon. That's what they mean, different composition. They do not have the same structure. Why? Because the atom numbers are not the same. Ethanol contains one oxygen atom, which is depicted by one red sphere based on the figure that we saw. In contrast, if you looked into your ethylene glycol, it contains two oxygen atoms. So this now make their composition to be different. So if you are taking a substance, maybe it's a medicine, or maybe you are taking something in form of a drink, that's why they will taste different. Things will look of different colors. Why? Because of the different composition. Even apparently, minor differences, what you might think just a small difference, in the composition or structure of molecule can cause, look into that, profound differences in their properties. So when you are mixing your chemicals, just a little bit of some change that you make or absence of something could trigger a massive difference in the composition of those chemicals. For example, let's do a comparison where we want to do a comparison between ethanol and the ethylene glycol, which have appeared to be quite similar. Ethanol is an alcohol in beverages. So for those people who drink, for example, beer or wine, it consists of ethanol. Whereas ethylene glycol is, look into that, viscous liquid used as a automobile antifreeze. Do you see now in terms of the operation? Very, very different. One is used, as an alcohol, which people can even consume as part of beer or part of wine and so forth. But the other one is used in the motor industry as an antifreeze and so forth. So what does this entail? It presents to you the different properties of matter. The properties of these two substances, they differ massively, as do their biological activities. They don't do the same job. So there's different products that get produced in factories, in industries. They need to consider such an aspect. So when you do your measurements, later which shall become a topic, you need to understand a slight difference in measurements could cause you to produce a different substance. Ethanol is consumed throughout the world, but you should never, look into this point, you should never consume ethylene glycol. Why? It is highly toxic, it can kill you. One of the challenges now, which is going to be presented before your table as chemistry, is for you to undertake, is to alter. You need to begin to change the composition of the structures so that you don't end up killing these people who are consuming, for instance, alcohol, who take it as a beverage or whatsoever. So now imagine if you failed to manipulate, then you ended up, instead of producing ethanol, you ended up with the ethylene glycol, which is highly toxic substance. That's now become a challenge before you. So the big question comes to you, how do you alter? How do you manipulate? How do you make changes, so that you produce the required substances? For example, the common drug, which is aspirin, the one that you just saw there, was first synthesized, that's produced in 1897 in a successful attempt to improve a natural product extracted from while back that had long been used to alleviate pain. Like we mentioned, everything came from observation from our forebears. So the brothers and sisters, our cousins, our aunties, our parents, grandparents who lived long time ago, they wanted to know how can they alleviate pain and so forth. So through trial and error, they were able to come up with certain chemicals, substances, and so forth. Every change in the observable world around you, from boiling water to the changes that occur as our bodies combat invading viruses, as its basic in the world of atoms and molecules. Thus, as we proceed with the study of chemistry, we will find ourselves thinking in two realms, two worlds. Number one, the macroscopic realm. That's the one that you see with your naked eyes. That's macroscopic, of ordinary size objects which are around you. And also in the sub-microscopic realm, which will require you to go at the atomic level into molecular things that you can't see with your naked eyes. Sometimes you need the electronic microscope, where you'll be seated in your laboratories and so forth. You want to investigate. So there are two. You've got the macroscopic and the sub-microscopic realm that you are dealing with. We make our observation in the macroscopic world to start with. But to understand the world better, we visually need to go a little bit into the atomic, into the molecular level, so that we understand what is happening. Chemistry is a science that seeks to understand the properties and behavior of matter by studying the properties and behaviors of the atoms and molecules that you are dealing with. So you can see, to sum it up, they show you, for example, in terms of energy, solar panels are composed of special treated silicon, Then in terms of biochemistry, the flash of the fire result from a chemical reaction in the insect. You have seen some of the insects, that have got this light that they produce due to the chemical reaction that take place in their body. In terms of medicine, chemists are constantly striving to design new, improved drugs for the treatment of disease. So they do a lot of experiments, investigation. Then in terms of technology, you can see in the OLEDs, organic light emitting diodes, are used in high-end cell phone, in your tablets, in your television, the colors that you see when you switch on your television, the colors that you see when you switch on your cell phone, your laptops, and so forth. Or it's part of the same processes of different chemicals and so forth. So I hope we understood this. So we are going first to take a break before we can proceed to the classification of matter. So thank you so much. And please, let's just continue. We shall be into the next lesson very soon. Thank you so much. Enjoy your day.